Welcome back! Are you good?
I'm good. Let's do it.
All right. So exponential functions. I'm going to talk a little bit first about exponential functions. This is called the base, the thing that is on the bottom for base. And this is called the exponent. Sometimes we call it the power. I got the power in me. All right. So that was all I had today. That's the excitement for Saturday morning. Yes. So notice that if we have an exponential function, the x is in the exponent. X is in the exponent for exponential. And all exponential functions are graphed very similar to this. They kind of got a horizontal asymptote and then whoop, they go crazy. Kind of like my pay when I retire from school and I get a real job, my pay is going to go whoop. Something like that. All right. Whoa, mommy! Sorry, I got excited. We took a picture of something. Do you want to talk about special exponential functions? Because I seem to always goof this number e up. So go for it.
Yeah. So this number e, you probably will.
It's my fault, really.
Okay. This number e is a number that comes up a lot in mathematics, especially in logarithms, and it comes from this limit as x approaches infinity. And this isn't really the proper way to write it. We would maybe write it as limit as x approaches infinity. That would be the notation.
Dude, I can't see you writing.
Okay.
There you
go.
go.
You got me. Okay. Of 1 plus 1 over x, that whole thing to the x. And what this means is, as if we take x values that get bigger and bigger and bigger and bigger, as close to infinity as we can get, which actually isn't that close. But as x gets really, really big, this limit approaches the number e.
Yeah, you know, we have numbers like pi and phi and things like that. I don't think we deal with phi all that much in high school. But this e is becoming extremely popular. In fact, they say it may overtake pi in popularity someday, kind of like at homecoming or something. All right. Now, you have a special button right on your calculator if you want to find e. On the TI whatever calculators, it's right above the ln button. It's an e to the x button. And so if we want to see what is e to the 1, we'll go second function, e, and let's raise that to the 1 power. That should spit back what approximately what e is. And it should be 2.718 something. So that's what I always remember, 2.718. Kind of like people remember pi is 3.14.
Right.
All right.
Yep.
So, and this does come up frequently, correct?
All the time.
Yeah, all the time. Math and science and in finance and things like that.
And nature.
And nature. All right.
And art.
Oh, mommy. There we go. And art? Wow.
I just keep making stuff up until we get to
that. That would be something to delve into deeper. All right, now we can model things with exponential functions, and so this is a population equation for Dallas from the 1900s, and it looks really ugly. I stole it out of our textbook here in St. Louis, but it's a 1.3 million over 1 plus 2.16 over e to the negative 0.05 something something t, and t is time in years. And notice that the t is in an exponent of e, so this is an exponential equation. It looks a little different than the one I said goes there because the e is on the bottom.
Right.
But I looked at this and I'm like, oh my goodness, this is going to take some pretty heavy math. And Mr. Creswell says, no, not in Mount Pleasant. We just graph the thing out. So, do you want me to run the calculator and you talk?
Yeah, go ahead. Yeah.
Okay, so essentially, how would you do this, Mr. Creswell?
So when I say I want the population to be 1 million,
you know, we didn't even read the question, did we?
According to the model, when was the population at 1 million? So this model gives us the population from 1900, for whenever. But I want to know when P of T. Oh, I'm good at this. I want to know when P of T is 1 million.
When this is 1 million?
Right. When the y value, if we were looking at it graphically, is 1 million.
Okay. So
to solve this, I think we learned that if we graph the ugly function and then the left-hand side of the function, which is 1 million, right? That's our P
you want
of
to
T.
write on there? Go right ahead.
Okay. If this is a 1 million, okay, and if I graph the left-hand side and the right-hand side of the functions, find the intersection, that's the solution. So
we typed this in, the ugly function, and we typed the million in, we hit graph, and it ends up looking something like that. Is that what you're?
Exactly. So this is our function, the curvy thing.
Go ahead
Can I
and
write?
draw it, yeah.
All right, that's our function, right? And then this is when y is 1,000,000. So the intersection right here should be our solution.
So do you want me to find the intersection
Yeah,
right
let's-
there?
let's,
All
let's
right.
just go
So
there.
so I think I go on our calculators. We go second calculate up here, and we want to calculate the intersection of those two. It says, what's the first curve? Well, yeah, that looks like the first curve. What's the second curve? Yeah. What's your guess? Well, something like that. And it says it's 84.5, something like that.
So what does that mean?
If the intersect at x is 84.5, what does that mean? Well, our data was from the 1900s,
Okay.
right? So if the data was 1900s, so if it started at 1900 and we intersected at 84.5, that's going to reach 1,000,000 sometime in 1984. Do you agree?
I agree. We're treating 1900 as 0.
All right. Thanks for taking our class.